Samit Nayak. Today I am present here presentation in the topic of HDFS. HDFS means Hadoop Distributed File System. What is Hadoop? This is the introduction slide. It tells that the presentation will cover what HDFS is, how its architecture works, how to install and configure HDFS, how to verify the installation, the sets the context for undertaking Hadoop storage. Second, next one is what is HDFS? HDFS stands for Hadoop Distributed File System. It is a storage system created by Hadoop to store very large data sets across multiple machines. Instead of storing a file on a single system, HDFS splits the file and distributes it across many computers. Key points: designed for big data workloads, provide high throughput for reading, writing data, automatically handles hardware failures, work efficiently on normal low-cost computers. HDFS turns hundreds or thousands of computers into one unified storage system. Key characteristics of HDFS. This slide highlight what make HDFS special. Fault tolerance. Fault tolerance means HDFS keeps multiple copies replies of each data block. If one node fails, data can still be accessed from another node. Designed for large files, HDFS is optimized for large file in GB or TB. It does not perform well for small files. Write once, read many files, usually written once and then read multiple times for analysis. Runs on concomitantly hardware. HDFS does not need expensive servers. It work on normal hardware, which mark it cost effective. Handles petabyte of data. HDFS can scale up easily to handle large data size. Fault tolerant architecture handles petabytes of data optimized for large files. Write once, read many access. Runs on concomitantly hardware. Next one is core architecture of components. Name node. Master server managing the file system namespace and regulating client access to files. Acts as the master of the file system. Manage the file system namespace, file names, directories, permissions, maintenance, metadata. Which block is stored on which data node? Very important. If name node fails, the cluster cannot function properly. Data nodes. Data nodes work are nodes storing actual data blocks and serving read write requests from clients. These are slave nodes in the cluster. They store the actual data blocks. They send heartbeat signals to name node to confirm they are live. Handle read write operation requested by clients. Secondary name node perform periodic checkpoints on the namespace supporting name node recovery. Of- Often misunderstood as a backup, it only takes periodic checkpoints of the metadata, helps reduce name node useful during recovery of rebuild file system. These are the core architecture of HDFS. Next slide, how HDFS works. First one is the data ingestion. When a file uploaded, it is a split into block. Default block size 128 or 256 GB. Files are split into blocks, typically 128 MB or distributed storage. Replication. Each block is replicated across multiple data nodes for tolerance. Each block is copied for three different data nodes. Different replication factor is equal to 3. This ensures high availability and fault tolerance. Example, if one data node fails, the block can be read from another node. Data retrieval. Name node directories clients to appreciate data nodes for reading data blocks. When a user wants a file, the client first contacts the name node. Name node provides the list of data nodes containing the required blocks. Client directly reads blocks from data nodes, not from the name node. This reduces the load on the name node and increase speed. Next slide. Key benefits of HDFS: high fault tolerance. Automatic data replication across nodes ensure no data loss even when hardware fails. The system continues operating seamlessly. Replication protects data from hardware failures. Even if multiple nodes fail, data remains safe. Scalability. Easily scaled from single servers to thousands of machines, each offering local computation and storage capacity. Next one is a cost effective, runs on commodity hardware rather than expensive specialized equipment, significantly reducing infrastructure costs. High throughput, optimized for batch processing with high data throughput rates, ideal for application requiring massive data. Next slide is pre-installation requirements. Hardware requirements: minimum 8 GB RAM per node, multi-core processor recommended, adequate disk space for data storage, reliable network connectivity, large data, uh, large disk storage. Uh, Next one is a software dependency. Java JDK 8 for higher installed SSH configure for passwordless access, network configuration, static IP address for all nodes, proper hostname resolution, firewall rules configured, adequate bandwidth between nodes. Next slide is installation process. Download Hadoop. Download from the Apache Hadoop official website and extract it. Obtain the latest stable Hadoop distribution from Apache official websites and extract to your installation directly. Configure environment. Set Java home and Hadoop home variables. Update code site.xml, LGFS site.xml, and MapRed site.xml configuration files. Format name node. Initialize the ADFS file system by formatting the name node before first use with the format command. Start device. Launch ADFS demos including name node and data node using start dpss.sh script to begin cluster operations. Next slide is essential configuration. Next slide is essential configuration files. Code site.xml defines fundamental Hadoop properties, including the default file system URL and temporary directory locations. LDFS site.xml has specific LDFS specific settings such as a replication factor, block size, and name node data node directories. Map site.xml configure map framework properties, including job tracker, address, and task memory allocation. Next slide is post installation. Post installation is check process, run JPS to ensure name node, data node, the secondary name node, resource manager, node manager are running. Access web UI, open browser, type the link. This show name node, dashboard live nodes, dead nodes, storage information, test file, operation. Use command like this: mktr root is dead. This confirm HDFS is working properly. Run simple jobs. Run built-in MapReduce example like word count to ensure full Hadoop functionality. Full loop functionality. Next slide is best practice and next step. Regular monitoring, keep checking cluster health, log, and storage. Backup strategy, backup name node metadata regularly because name node is a critical performance and adjust block size, replication factor, memory allocation based on workload. Security, implement servers, authentication, access control, and encryption to protect sensitive data. Thanks everyone. This is the best practice and next steps. Regular monitoring is a very useful for HDFS and it's a very important both our life and whole data visualize. Thank you everyone.